Hi all, I'm Giovanni Bekis. I'm one of the OpenBSD developers. I use OpenBSD for a lot of things. This time I will talk about RelayD. RelayD is a proxy software. It can do a lot of things. It was imported as a load balancer. Then it becomes a real proxy. It can do. It can be used for as a reverse proxy, as an SSL accelerated reverse proxy, so to handle SSL connections. As a transport point proxy with filtering capabilities, so it can filter HTTP traffic, for example, before relaying to the web server. It can do application redirector, so it can relay whatever connection, even if it doesn't know anything about the protocol. So it can do, for example, terminal server connections to many Windows machines, even if nobody knows quite all about the RDP protocol. It can do. It can be a load balancer, which is the main use of RelayD. Then it can be also a one-link balancer, so you can use in a firewall to balance between internet connections. If you have, for example, two internet connections with two different routers, it can balance your connection on one or both router you're using. It was first important in OpenBSD 4.1. At the moment, a couple of days ago, OpenBSD 5.1 was released. We do a release every 6 months, so it's 5 years old. Initially, it was imported as with the name of host stated, because the main purpose was to check availability of remote hosts. Then it was renamed in OpenBSD 4.3 to RelayD because it began to do a lot of things. So we thought that host-stated was not the right name for this software. It was written mostly by Pierre-Yves Richard and Reich Flöder. Some other hackers put some fix or some other features on it, but most work was done by them. It was written with security in mind, as all good software should be, and is based on iMessage framework. iMessage framework is a framework in libutil we use for inter-process communication. So we have a set of functions called iMessage compose or iMessage send, iMessage write, message init, etc. to do correct inter-process communication without reinvent the wheel every time we need to write communication between parent and child processes. It's IPv4 and IPv6 is capable, so it runs fine on both connectivities. It's CARP capable. CARP, it's a protocol which is used to do firewall clusters. So you can have a virtual IP with many nodes behind him, and it's integrated with SNMPD, which is another daemon. So relay D can send trap to an SNMPD software to when a host check state changes. So you have beautiful graphs, statistics, and so on, that some people like. Okay, so relay D is divided in a main parent process and 3 different engines. We have the parent process, which is the only process which is run as root. Then we have other child processes which are pre-forked and could be forked later if we need more resources. And we have the host check engine, which checks the state of the hosts of the nodes we want to check. The PFE engine, which it's used to interact with the packet filter, so to add on-the-fly rules in PF to redirect connection to machine, and the relay engine, which is the proxy, which checks layer 3 and layer 7 traffic and acts as a proxy, so relay connections to the real servers. Well, the parent process is the only one that runs as root. It runs as root because it needs to read configurations files, which are owned by root. It needs to set up a control socket, which is used then by the client part of the software to interact with relay D. It needs in the relay part to listen to, for example, a high level port, so a port with numbers -10 1024 that needs root to be opened, to bind. It needs to sometimes to call in certain configurations external scripts to check for host availability. So privileges in this case will be dropped to the relay D user before the XLP function call. So the script will be executed with the relay privileges in the ch root of the user. Then it can do carp demotion requests, and root privileges are needed for that. The host check engine uses many methods to verify that the target is live. The easiest one is ICMP check. So it checks by sending an ICMP packet if the host is dead or is live. But in many cases this is not a good idea, because a service could be down, or we could have other problems, for example. We can do a TCP connection, so the relay check the freeway handshake TCP connection to the host, and this is used mainly when we are not doing HTTP, or we cannot use external script to check the other host, for example, where we are proxying some services we do not know nothing about the protocol. So it could be a service running on Microsoft Windows, for example. Then we have SSL, which do SSL and shake, the HTTPS part, and external scripts. With external scripts, we can do whatever we want, because it runs a script which could be, well, it's a program which it could be written in Perl, C, Python, Ruby, or whatever else, and it accepts the host you want to check, and it should return true or false. In the program you can do whatever check you want. The packet filter creates and destroys PF rules, updates PF tables based on AC notification. In this kind of setup, we have a table in PF with all the hosts we want to check. The PF engine checks for host availability and then disable or enable the hosts that are alive. So PF redirects packets based on the content of this table. The relay engine filters packets and relay packets. So creates listening sockets for services. If you want, for example, to relay HTTP, it's binded to the standard 80 port and filters protocols, mainly HTTP, before start to relay software. This example, the HTTP proxy, we got internet. We got a relay ID, which is our proxy, and a web server, which could be running on any operating system. Okay, we have first of all we have a table which could be of one host or of many hosts, if you want to balance connection. We have some standard configuration, which is the interval between checks. By default is 10 seconds, but we'd like to improve or not this one. We got a timeout in milliseconds of the response. We got pre-fork, so how many processes we want to fork at the start of the program. And log updates, if you want to log to syslog only updates of state changes, or we could have a log all if you want to log all states. So we will have on syslog a line every 10 seconds, even if all is up and nothing changes. Then we want to listen to our IP address, which could be IPv4 or IPv6 with a port, and then we forward our request to our web host. In this case, we'll check that the HTTP call to the main route of the web server will be okay. So we'll have a response code of 2000. A bit more complicated. This setup, we have the possibility to check more info on our web server. Because, for example, with a website will run if Apache, for example, is running. but with a simple HTTP check, we do not know if memcache is running or if the MySQL backend server is running or whatever else. So if we want to check more complex things, we have to use a script like this one. It accepts a remote address, then it tries to connect to the HTTP port, then it tries to connect to the main cache port, and if it all goes well, it returns a true value, otherwise it returns a false value. Well, this has been streamed down without any check about anything to put it on slide. Anyway, in this way we can do whatever we want. In more complicated example, we can from this page we can for example, do an HTTP connection to a backend web server running Windows if you want to check, for example, that the SQL server is running correctly, or other things that are not so easy to check from a BSD host. In reverse proxy configuration, we can filter HTTP requests. We can change. We can filter both headers and body. So we can change or append HTTP requests. We can filter by checking HTTP headers, or by checking URL, or by checking paths. We can filter also by checking the response of the web server. Okay, so we have a return error, which is which means that we want to return an error page if our filter matches. We will, in this case, we will append an x-forwarded for header, because on our backend server we want on the log files an additional header for statistics purposes, because otherwise all with this configuration, all connection to the backend web server will be from the relay proxy. So we will have in our log files all connections coming from this IP. With the x-forwarded for, we have an additional header with the real IP which is doing connection. We want to filter this path. The main problem here is that our customer is using a bad written Windows application which nobody maintains no more. It doesn't want to change, but it has security problems. So we want to filter some well-known security script, security problems to prevent attacks, well-known attacks. Then we want to change another header, which is the connection. We will close the connection, because once we have proxying the connection to the real web server, we want to close our connection. Otherwise, the connection will close with standard timeout TCP values. So we will have a lot of connection in our proxy that will time out very, very lately. Okay, we will try to do a well-known kind of attack to our Windows web server, and we are blocked by relay D. This is the standard page, but in configuration we could add style sheet in CSS, so we can design whatever we want. Relay supports all HTTP methods, so head, get, put, post options, whatever you want. Another useful thing is accelerated reverse HTTP proxy. We want to doing the crypto part of the connection on our proxy, because, for example, we do not want to handle certificates to all our web server, or because it could be complicated to handle crypto on our backend server. This way, we decide to accept SSL-v3, TLS-v1, only high ciphers, but not Diffie-Hellman protocol, and we do not want SSL-v2. So if the requirements are respected, the SSL connection goes well, and we relay to our internal web server. This way we have a secure connection from internet to our proxy, and then a plain connection from our proxy to our internal web server. Relay work is doing the crypt and decrypt of all connection between all the client and the server. We'll use OpenSSL to create our certificate. We could create a private certificate by ourselves, or we could take our sister file, give to VeriSign, author or other CA, and grab the file signed by the certification authority. We'll put in the right place the certificate, and it should work. We could use it as a transparent HTTP proxy. For example, if you want to filter our LAN, the filtering mechanism is very simple. Mostly because the URL filtering is using internally the fmatch function. So the regular expression you can use are a bit limited, and it's not a real regex engine. This is because if you have a lot of rules, it could be a little slow. This way is a transparent proxy. For example, we could replace Squid if you do not want all the features Squid has. It doesn't work as a real proxy, it works only as a transparent proxy. So we, with PF, we redirect connections to our relay engine. And for example, we want to block requests to some website which is mostly unuseful for work. We listen to in localhost to port 8008. You add the protocol HTTP filter, so we use the previous definition of the protocol to filter our requests. The error message is similar to the previous one, so the red quite audible page. In past version, we could have a label, so we could unblock the request. We could add an additional line on the web page to explain why the site was blocked. At the time, it's been partially disabled because there was a bug in it, so we're trying to fix it. Another useful thing is application redirector, so we have more hosts and we relay connection to our backend server. We use the redirect this time, so PF is involved. We listen on a public IP port. We add a tag which is used by PF to handle connections in and out. We add sticky address because we need that connection made to a host returning packets should go to the same host originated. And we have mode round robin. We can have mode round robin or mode load balance if you want to balance connections. This time we have check TCP, but in some cases, for example, with MySQL, we could write a simple script to check that MySQL connection goes right. Load balancer. This is a balancing connection between two DNS servers. So the main difference is that we balance connection and we do not do round robin. So we do not try to connect to the both hosts one time to a host, one time to another. We have in this configuration we have a protocol, so we set some TCP configuration to improve TCP performance. We improved the buffer and we had no delay option. This is done, for example, in DNS. This should be done if you want to use SSH. If you do not want that long delay when you type something on the host, for example, on slow connections. Then we got the client part, which is relay control, which is the software to control the daemon, relay D. It can change at runtime a lot of configurations. It can show many information about our relay D setup, about how it's running, which hosts are up or which hosts are down. It can reload configuration and so on. It uses the control socket in var directory to communicate via IPC with the daemon. In this example, we have a connection between IP address to the report ACD of our relay D. We have when the connection was established, how many times it's idle, and which is the relay we are using, and the process ID. Then we have the table of our host. So in this example, we have 3 hosts, and all hosts are up. With the redirected setup, the output is a bit different, but we have which hosts are up or down. With the redirect setup, relay D interacts with PF. So it creates a runtime PF rules on an anchor under the relay D group. So in this example, for example, we have on the relay D anchor a MySQL group with some rules. We have a rule which passes packets on the root domain 0 from any to our MySQL server with some options added by relay D. In a real configuration, we will have probably many rules with that. Then we can have monitoring. We could monitor with relay control by console, or we could monitor with SNMPD trap. So we can send a trap when a state hot changes to our SNMPD daemon. Then with the SNMPD we can do graph with RRD tool or other software. Or we could use some plugin in iOS or in Moonin. Some of them are in standard installation. Some of them are script written by someone else, which are easily found in internet. So you could have a graph of the reliability of your proxy engine, which some people like most.